corner. Uh, I'm going to do a quick intro into kind of the review of what's in Chapter 9 here with the rotational stuff. Well, actually, the very end. And then I'm going to do like 3 of your problems in the next couple tracks. Problem 21 was kind of tricky. But again, they're not tricky if you just break them down into everything that they're asking and remember the basics of what's going on. All right, so without further ado, let's take a look at. So I'm going to knock my mug off that screws things up when that's on, and I turn this guy on. All right, so here's the basic idea. All right, I think you've got the idea of what we did in the first 3 sections of Chapter 9, where we were finding the torques and the sum of the forces, which is actually Chapter 21, or Problem 21. But the next thing we're doing is, say I want to start a lawnmower, and so here's the pulley to get the lawnmower started with the little thing here, and I pull on this really hard with a force like that. I pull on that with a really hard force. Now that's a tangential force to this pulley, which is going to make it go this way, which is actually a negative torque, but that doesn't matter. We just wanted to get it to spin so that it fires the spark plug. It spins fast enough to get the spark plug to get a little bit of oil and to create enough energy where boom, it'll hit that spark plug. Basically, we're turning mechanical energy into chemical energy, into that combustive force. So we get that to go, and this thing has a radius of r, and so now this is starting from rest, so omega naught equals 0, but then it's got an omega final, all right? So it'll have some omega final at the end. Well, so therefore it's got to have an angular acceleration, must have, all right? And we know that F times R is equal to the torque, which is equal to the I times alpha, where I of a disk, of a solid disk, which is the moment of inertia, is equal to 1/2 mR squared. Okay, so this is where m is the mass of the disk, equals m. R is radius of the disk. So there's my acceleration that's going to happen over a short amount of time to get this final omega final, okay? And then once this thing is spinning, and so the rotational energy that I use, the rotational energy, say this thing is pinned down like it is on a lawnmower starter, because it's not going to, I'm not going to get it to roll and it's going to start rolling. All right, it's not going to take off rolling this way or anything. So it's rotational energy. So here's what happens. Here's what happens. This, notice we got mR squared, so this force is equal to R times alpha. So we've got this FTR is also equal to I times alpha. All right. Okay. And so, which is also the work done on it. That's analogous to the work. It's kind of analogous to F equals ma. But now that we add this force, look, we've got a force times R. That's the same thing as work. Okay, this is work. Force times a distance R. Sort of. I mean, it is. Because we're getting the pins of this to move on the outside. Here I am trying to explain. I hope I didn't muddy the waters. But the rotational energy then, the change in rotational energy, Ke rotational, is equal to 1/2 I omega final squared minus 1/2 I omega naught squared. All right, then the very last thing, and I'll stop this intro, then the very last thing is conservation of angular momentum. which you might have one of these on your exam. And it's not hard. This is the ice skater spinning problem, all right, which says, basically this says that L naught is equal to L final, where L is equal to I times omega. The moment of inertia times its spin, just like analogous to P, which is equal to mv. Notice, moment of inertia, inertia times v, moment of inertia times the angular speed. Same thing. And basically we have I naught, omega naught. Now what happens, what's different from when we're doing momentum, well actually momentum, the masses were changing. For an inelastic collision, we'd add the masses together, and I final, omega final. Okay? That's your conservation of angular momentum. And I will do 3 of your problems now from your homework so that you can see it. And you'll have time to study it before the exam.